Proving you're not a robot when you are surfing through the internet is one of a tricky task. There are checks which are known as CAPTCHA challenges. A CAPTCHA is actually completely automated public Turing test to tell computers and humans apart. It's a type of challenge or response test used in computing community to determine whether or not you are a human or a robot. I'm not going to talk about CAPTCHA today, but there's a key word here, Turing. Alan Turing is my favorite scientist, and in today's episode of Glitch, we'll be talking about this great mathematician and why is he known as the father of modern computers. Let's go to the episode. Hi, welcome to Glitch, a podcast exploring tech news, how stuff works, innovation in our day-to-day technology, and the news surrounding them. I'm your host Vikram. I'm so excited that you are here. Thanks for joining with me today. As anyone who can operate a personal computer knows, the way to make the machine perform some desired task is to write a program. Life was not always so simple. The earliest large-scale digital computers did not store program in their memory. To set up these computers for a fresh task, it was necessary to modify some of the machine's wiring, rerouting the cables by hand or setting switches. Turing has always been famous among the computer scientists for generations. But in recent years, he has grown as a cultural icon. And now millions of people know him because of the movie The Imitation Game. Well, I'm not going to talk anything about the movie here. Instead, I'm going to talk about what The Imitation Game didn't tell you about Turing's greatest invention for us. The movie focuses on Turing's heroics in World War II when he worked for the British intelligence service and played the key role in breaking the German Enigma code. We see Turing laboring obsessively over the building of code-breaking machine. After the war, he is still tinkering with an elaborate piece of hardware. The movie closes with a valediction saying, his mission was never perfected. Though it generated a whole field of research into what became known as Turing machines, today we call them computers. In reality, Turing's greatest breakthrough wasn't mechanical, but more of theoretical. I thought we will cover the basic idea behind Turing's mission because they are powerful devices with an interesting property. They are not physical devices, but rather abstract mathematical models. Back in 30s, mathematicians were fascinated by this decision problem. A decision problem is fundamental to logic. It is concerned with the validity of statements. For example, let's just take this statement. It rains when it's raining. It's a true statement. And it rains when it's not raining is a false statement. This is the fundamental for a decision problem. And Turing was interested in this question. Just how much maths can we do, not by using our gut feeling or intuitions, but just by following rules very, very carefully. Turing called this an effective procedure. Today, an effective procedure is said to be an algorithm, but back in 30s, the concept of algorithm was very vague. The machine developed by Turing can mathematically describe any operation that a modern computer can perform, just by following simple rules. You just need to have a way of writing down the information in a coded form. Turing's way was to just think of a tape or a memory, which can be as long as it needs to be and is divided into infinite number of square cells. Now let me just try to describe how this concept of Turing's machine works in the simplest form possible. Imagine each cell holds a 0 or 1, which can be read or overwritten by the machine's read or write head. Now you can imagine it as a little box running above the tape, looking at one square at a time and to check to read it or write. There is more goes into this Turing's machine like states and transitions, but which for now I think I can just say, you can understand it as it says, the states of a machine at any given time. The machine starts by reading the data present at the cells and rewrites it according to a set of instructions. These instructions also tells the machine which direction to move. The machine follows a read, write, and move cycle over and over and over again until it's told to halt. The information written on the tape at the end of this operation can be called as the output. And in our case, we can say the computation is complete. This wonderful idea of Turing machines are the blueprint for any modern day computers. Anything from your desktop to your smartphones or the computers in the International Space Station are based on Turing's model. Anything that any of these machines can do can in principle be done by Turing's model. It might take a bit longer though. Even though the model was conceived more than 90 years ago, currently there are no working model for computation which is more powerful than Turing's. Anything that can be computed can in principle be done by Turing's machine. If a Turing's machine can't compute it, it's not computable. That's not to say that this might not change someday. Another model of computation which has been in the tech news rather recently is the quantum computing, which is my favorite, which if they work in conventional use cases will definitely bring something new to the table. But so far, Turing's simple model is still most widely spread model of computation till date. I think with this we have come to the end of today's episode. I just wanted to have an episode of Turing because for me his mindset is the biggest glitch in the computation domain itself. Turing's legacy is huge. We live in the world full of computers thanks to his work, the basic principle of modern computer. The idea of controlling the machine's operation by means of programming instructions and storing it in a computer's memory was conceived by Alan Turing. Thank you so much for listening to Glitch. Let me meet you in next interesting episode. Until then, it's bye from Vikram.